On some occasions, it will be necessary to include more than one delivery point within a gathering system model. Currently, there is a single delivery point on screen with a pressure of 900 psi. Let's add a second one over here to the west, about a mile away. It also has, by default, a pressure of 900 psi. And let's connect the two with a 3-inch pipe. What might we expect to have happen? If there were any rate in this system, we would expect half to go east and half to go west. Let's run a present forecast. You'll notice down in the status window that we get an error message. A looped link is attached to a delivery point. In our previous recording about loop links, you will have learned that a designated loop link should not touch a facility. How do we fix this? The simplest way is to right-click on the link and simply split it. And we need to do that on each end next to a delivery point. So now we should not have to have a loop link touching a delivery point. Let's update that forecast. And you'll notice that everything ran fine. We have a designated loop link between the two delivery points. Currently, this isn't a very interesting system. Really not a lot's going to be happening. The pressure at each end, at each delivery point is exactly the same. What happens if we change one of them? Let's right-click on the delivery point in the east, and we're going to add. And let's change this pressure to 880 psi and say OK. And update that forecast. You'll notice that if we check the direction of flow, it's going from high pressure, the west delivery point with 900 psi, to the east one at 800 psi. Let's go back to our annotations, and I'm just quickly going to annotate the gas rate under standard conditions. You might be asking yourself why. Well, you'll notice that even though there is no rate being added into this model, a gas rate of 4.172 million has been provided by the delivery point. It's actually entering the gathering system, going to the other delivery point, same rate, in order to fulfill the 20-pound frictional pressure loss between the two of them. This might seem like an unusual result. The thing to bear in mind is that all calculations within IHS Piper occur from the delivery point going upstream. The delivery point is fixed. That pressure is not changeable. Whatever you set it at is static. The application will add as much gas as necessary in order to achieve the pressure loss calculated between these 2 points. Let's make things a little bit more interesting and add a source of gas. I'm just going to right-click on this link, split it. We're going to add a fixed rate well, and I'm going to connect it in with a 3-inch line again. And let's go ahead and set the rate for that well. So I'm going to right-click, fixed rate well, edit, and on well deliverability, let's set it to 10 million. What might we expect to have happen? We have 10 million a day that can flow to one of 2 delivery points. The frictional pressure loss on each side should be approximately the same. They're the same diameter pipe and they're about the same length. We have a pressure difference at the delivery points of 20 pounds, 900 versus 880. So you might ask yourself, to which side, which delivery point 1 or delivery point 2, would you expect more gas to be delivered to. Let's go ahead and run that forecast. You'll notice that the arrows on the links indicate we do have flow away from the well, and we have flow both to the west and to the east. The gas rate at delivery point 2, which has the 900 psi, is 3.2 million, while the rate over at delivery point 1 in the east is 6.7. And this result is reasonable. We have a lower pressure, so the pressure difference between this well and this delivery point is greater, and thereby we would expect more flow to go to this delivery point rather than delivery point 2. What can we take away from all of this? It is possible to model multiple delivery points within your gathering system. You do want to have a good understanding of what the actual pressure is at each of those delivery points, and bear in mind that all calculations are done from the delivery point upstream. When there are multiple delivery points in place, if required, it is possible that your delivery point can input gas into the system if necessary to make the pressure calculations add up properly. And finally, whenever you have two delivery points or more within a gathering system, there must be a designated loop link between the two of them. Even though there is no flow loop in this example, there is a split in flow path. So gas can travel more than one direction, and because of that, there needs to be a designated loop link within this gathering system model.